Welcome to Python tutorial, lesson 24. Today we learn iterators and generators. These produce values lazily, one at a time. An iterator produces values one at a time when you loop over it. It needs dunder iter to start and dunder next for each value. When values run out, it raises StopIteration. Let us create Iterator_basics.py. Countdown stores a start value. Dunder iter resets current and returns self. Dunder next decrements until it reaches 0, then raises StopIteration. The for loop calls dunder iter, then dunder next repeatedly. It counts 5 down to 1. Manual iteration shows what the for loop does behind the scenes. We call iter to get the iterator, then next 3 times. EvenNumbers works the same way but increments by 2 each step. It stops when current exceeds the limit. We convert EvenNumbers to a list and also iterate with a for loop. Let us review the code with BAT. Now let us run the code. Countdown prints 5 through 1. Manual iteration calls next 3 times, then StopIteration fires. EvenNumbers produces 2 through 10 as a list and up to 20 in the loop. A generator is a simpler way to create iterators using yield. Each yield pauses the function. The next call resumes where it left off. Generators save memory by producing values on demand. Let us create generator_functions.py. We import sys to compare memory sizes later. This countdown generator does the same as our countdown class, but in just 4 lines. Yield pauses the function and sends a value back. A list comprehension stores all values in memory. A generator expression uses parentheses instead and produces values lazily. This Fibonacci generator yields each number in the sequence. It keeps going until it exceeds the limit. Generator pipelines chain small functions together. Numbers produces values, double multiplies by 2, and keep even filters odd ones out. The result flows through all three generators without storing intermediate lists. Yield from delegates to another generator. Outer yields start, then all values from inner, then end. Let us review the code with BAT. Now let us run the code. The list uses 8,856 bytes, but the generator only needs 208, a huge memory saving. The pipeline gives even doubled numbers. Yield from combine start, 1, 2, and end. Our mini project builds a data processing pipeline with generators. Each step reads, filters, transforms, or batches records lazily. The pipeline processes data without loading everything into memory at once. Let us create data_pipeline.py. We import date for the summary timestamp. Read records is our data source. It yields 10 dictionaries with name, status, and score. Some records are active and some inactive. This lets us test our filter. Filter active only yields records where status equals active. Inactive ones are silently skipped. Transform names converts each name to title case using .title. It yields the modified record. Batch process collects records into groups of n. It yields each full batch, plus any remaining items at the end. Step 1 reads all 10 records. Step 2 filters to only the 7 active ones and prints each name and score. Step 3 chains filter into transform. Now names come back in title case like Alice Smith instead of lowercase. Batch processing groups the pipeline output into batches of 3. The last batch gets whatever remains. The summary computes count, average, highest, and lowest scores from the full pipeline. Let us review the full code with BAT. Now let us run the data pipeline. Ten records filter down to 7 active ones. Names change from lowercase to title case. 3 batches appear and the average score is 86.9 across all active records. Let us recap iterators and generators. Iterators use dunder, iter, and dunder next. Generators use yield to pause and save memory. Chain generators into pipelines for clean processing. Thanks for watching. Subscribe for more Python tutorials. In the next lesson, we cover context managers.